Okay, hello everyone. This is a production from the RTL team. Okay, as a starter, we are going to watch a recording showing the functionality of the Embarcadero BeaconFence component, recreating the offices in Spain. We will ask the system to lead us from the office's entrance to the meeting room. In the way, we will change the recommended path for another one, so we'll see how the system redirects us, offering an alternative route. We will get into a colleague's office, and finally we'll get our destination, where an arrival event will advertise us about it. In the video we will show all the time the recording of the real world as well as the map created by the BeaconFence component showing our position. Enjoy it. Thanks. Hello everyone, and welcome to the Code Rage 10. I'm Jorge Alcalde from the RTL team, and I'm going to talk about some technical features of the BeaconFence component, some good practice and points to have in consideration to obtain really good results, therefore be able to develop a robust application. Okay, first of all, we are going to turn back defining what a Bluetooth beacon is. A beacon is a Bluetooth low energy device that is continuously telling to the world, here I am and this is my name. This advertisement is produced through the advertised data packet, where all this data is encapsulated as UID major and minor, allowing any device that receives that information to identify that beacon, having the possibility of calculating an estimated distance to it, without being paired or connected, thanks to its received signal strength indicator loss, RSA. A geofence is a virtual perimeter for a real-world geographical area. A geofence can be a predefined set of boundaries, like school attendance zones or neighborhood boundaries, when the location-aware device of a location-based service user enters or exits a geofence. The device receives a generated notification. Geofencing is used today at triangulating the GPS position of a device. Putting the two together, the idea is to use beacons to implement a geofencing within a building. Think of a shopping mall or an industrial environment, a museum or a school. So, BeaconFence enables developers to take proximity beacons to the next level by adding precision spatial location awareness to their application, both indoor and outdoor. The signals from beacons is tremendously noisy, especially indoors. Radio signals jump and bounce around constantly. walls, electrical devices, electrical wiring, different mobile devices, Wi-Fi, and even people becomes in absorption, interference, or diffraction of the signal. So, beacon standard is not primarily designed for indoor positioning. It is in principle focused in proximity. A really advanced noise smoothing algorithm as well as some recommended practice are needed depending on the purpose for our BeaconFence application. Different steps we must bear in mind when we try to approximate our input beacon data measures. There are some webs from beacons provider where we can find complete information about it. So here I am going to highlight those specification and steps that I find the most important. The first and most important of all steps is the beacon calibration. The calibration of the beacon TX power. A beacon transmission includes a transmitted power field that indicates how strong the signal should be at a known distance. Beacons must be calibrated by measuring the signal level RSSA at this reference distance and then configuring the beacon to transmit reference value. Without a proper beacon calibration, we can get a really wrong estimated distance resulting in a mistaken position estimation, mainly because the algorithm can take as a distant beacon a nearby one and vice versa. Use the strongest transmitted power level supported by your beacon if possible, and if the use case allows for it. Stronger signal levels mean higher signal to noise ratios and better distance estimates. Use the highest transmission frequency supported by your beacon. The more advertising packets received by a mobile device, the more samples it will have to average to filter out noise. Use powered beacons where possible, so that you can transmit a high power and a high frequency without worrying about battery life. Place beacons in a location with a clear line of sight to where the signal will be received. If in a crowded location, placements overhead works better than those at ground level. Place beacons wherever there is an intersection in a path. This could be beginning or ending of a corridor, corners, room, entrance, etc. Okay, I'm going to show you the places where we had located our beacons, and as I recommended before, we locate them, some of them on the roof, as you saw. And for example, especially for this corridor, I recommend to put one of them on the beginning of the corridor, another one on the end of the corridor, and no more distance of 10 meters. As you saw, I put, if you in each transition or the path you want to positioning, then this is a nice idea to put a beacon. So on the top of a door or in each corner you find. So as you see in this video where we locate ours. Another corridor, one at the beginning or the end, as you see, and the other on the roof there, another beacon. Yes, in our demo we were using 3 beacons for the location algorithm. It's quite enough for the corridors, and if you have an empty space like this one, it's better if you use more, 4 or 5. Look, another one for the beginning of this corridor or ending. If you are planning on deploying an application for a specific place, make sure that you have a distance estimation formula optimized for that model. Make use of the SPC, Signal Propagation Constant, property from Beacons Manager option of the BeaconFence component. SPC for different environments taken from the book Zigbee Wireless Network and transceivers we can see in the attached. Let's note that the SPC property will take the reciprocal value from those exposed on the table. An indoor positioning system is a solution to locate objects or people inside a building using radio waves, magnetic fields, acoustic signal, or other sensor information collected by a mobile device, in our case Bluetooth Low Energy. As a main tool to solve this problem in our component, we have made use of the special probabilistic filter called particle filter location, also known as a Monte Carlo location, MCL. MCL is an algorithm for robots to localize using a particle filter given a map to the environment. The algorithm estimates the position on and orientation of a robot as it moves and senses the environment. The algorithm uses a particle filter to represent the distribution of likely states, which each particle represents a possible state. This is a hypothesis of where the robot is. The algorithm typically starts with an uniform random distribution of particles over the configuration space, meaning the robot has no information on where it is and assumes it is equally likely to be at any point in space. Whenever the robot moves, it shifts the particles to predict its new state after the movement. Whenever the robot sends something, the particles are resampled based on recursive Bayesian estimation. This is how well the actual sense data correlate with the predicted state. Ultimately, the particle should converge towards the actual position of the robots. So, it is obvious that for our purpose, the mentioned robot will be a Bluetooth LE mobile user and the sense data, the estimated distance to each beacon.
Hello there, this is Ivan Gracia from RTL team, and I'm going to introduce you on fencing components. The first thing we need is to get the fencing components into the IDE. To get fencing components, we should use Get It Package Manager. You can find on the Tools menu. Once open, you just need to press Install on the fence component and let Get It download and install on the IDE. Once the installation has finished, close Get It and create a new multi-device application. In order to see the fencing components, you should select Android, iOS or OS X as the platform for the project. So we can look for fencing in the tool palette, and we should see two components, Beacon Map Fencing and Beacon Zones Fencing. Also, the package comes with two demos applications, one for each component. We just need to open Documents, Embarcadero, Studio, 17, Catalog Repository, BeaconFence, Samples. If you don't see anything there, it's because there is a zip file with the demos. You just need to unzip it on the same folder and you will see one folder for each demo. So the first one is for the Beacon Map Fencing component. That is a map fencing application that allows you to run several maps in the device. And the second sample is for the zone fencing component. It's a more simple application, just showing events for beacons. Later we'll see them working. Okay, so now I'm going to show you how beacon zones fencing component works. So this component allows us to define zones and include beacons inside those zones in order we'll get events for those beacons at defined zones. To better see how it works, I'm going to create a simple application where we are going to change the color of a rectangle that will represent a zone and the color of a circle that will represent a beacon. So we create a new multi-device application. First change the platform to Android and look for the fencing component in the tool palette and add the beacon zones fencing component. So first thing I'm going to do is to add zones and beacons information to the component. A good note before to start is to fill up the base beacon identifier that will be used later to help us to fill up the information of the beacons, as normally all the beacons we are going to use have the same identifier. So on this case I'm going to use the one for our beacons. Okay, so clicking on the zones property, we open the zones editor. I'm going to add two zones and I'm going to set the beacon proximity property to immediate. This will mean that the zone events are going to be fired when a beacon inside them is on an immediate state. We can change the name for each zone. Okay. And for this sample I'm going to add one beacon for each zone. For example, this is going to be major 1 and minor 1, and for the second zone we have another beacon. This one is major 1 and minor 2. Okay, so this is the only thing we need to add for the beacons and zones. So when the component is enabled, we are going to get the events for zones and beacons. So for show how it works, I'm going to add two rectangles, one for each zone, and two circles to represent the beacons. Okay. Also I'm going to add a button to activate the component at runtime. Okay. To make easier work with the events, we have a property for zones and beacons where we can hold a reference to an object. In this case, I'm going to use them to hold a reference to the rectangles and the circles in order on the events we have that information. So for example, on the create event for the form, we access to the zones and data and the beacons. So just assigning the context property to the first rectangle and the second, and the same for the beacons. Okay. Now I'm going to write the handlers for the events and change the color. I'm going to change to green color when we enter to a beacon, red color when we exit from a beacon. That will means that the beacon signal has been lost, and the same for the zones. So for the beacon enter, as we have the beacon item here, we just need to cast the context property to the circle to get access to the circle that we have attached on the context property. The same on the zone exit, now using on red, and also for the zone and enter and zone exit events, just changing the circle for the rectangle. Okay, so this is all that we need to run this demo application. So let's go see how it works on a device. The two beacons are working right now, so I'm going to start. You can see the two beacons have changed the color, and now I'm near of the first beacon, so the zone has been changed to green, and I need to move the the device to the second beacon. As you can see, the second zone has changed to green and the first one to red. So that is simple and it's how it works. Thank you. Okay, now I'm going to introduce you to the beacon map fencing component. This component allows us to create a map, placing beacons, defining zones and paths. This is going to be used to fire events, and also is going to be painted on a FireMonkey component at runtime. The component holds a cat editor where we can use an image as base or the map, set the scale and configure all beacon setup. I'm using the beacon map fencing application example that comes with the beacon fencing package. So to show the editor, we just need to double click over the component and you will see an empty project. So the first thing we need to do is to create a map. We will see a square. We can change the background color, but the most useful thing is to have an image to help us to fill the beacon's locations and to be shown later in the at runtime. So we are going to load. This is an image of the office. So once we have a background, we need to say the measure of the map. We have a tool that's called scale map that allows us to change the distance between 2 points. In this case, this wall on the top, we know that it's near of 11 meters, so we just click on them and we place the new measure. You can see the map has been rescaled. Now it's time to add beacons. Using the beacon tool, we can add beacons around the office. As we have seen on the previous presentation, we need to make a field test in order to place correctly beacons. So I'm going to place beacons as we have configured on this office. Okay, so something like that. As you can see, we used to have beacons at the beginning, at the end of the corridors, and so on. Okay, we should set the properties for each beacon here. We can change the name and we can set up its identifier, major and minor. All those values are used later by the internal beacon manager to catch the signal of all of them. Okay, the map editor also allows us to define zones. We have the possibility to define rectangular zones, circular zones and polygonal zones, in order that when the fencing detects that we are over that zone, an event will be fired. Also the zone will be highlighted on the painted runtime map. So to add zones, just select the tool and add the zone. The same for the circular zones. And for the polygonal zones, we just click on the first point and add several points to create the polygonal form you need. All zones types have the same properties. We can change the color to distinguish them, and also we can change the name. Finally, we have also the path tool. This is important because we're going to provide two positions. One will be the raw position and the second will be a position adjust to the path. This will make that our position will be more stable. So we just need to add paths where we want to see the position. For example, on our office, on the first video you have seen on the presentation, the path is something like that. The path also will be used to provide a minimal path from each point to another. That way a user can search for a point and will be addressed to it. Okay, something like that. Okay. All those components, beacons, zones and path points are automatically added as point of interest. The component will provide a list with all the point of interest, and we also have for all of them a description list. This description list can be used to add more information to a point in order that later we can search the point of interest list looking for one point. For example, we can say that this zone have developers that way. When we search for developer, this zone will be find as one of the possible results. Okay, we can add several maps with this editor. For example, if we have two floors in our setup environment, so on our case we have another floor, we just need to create a new map. The same steps, we load another image and we also set the scale for this wall. Okay, so we also can have some beacons here. And when we are at runtime, the map will change automatically depending on the beacons detected. So if we detect that we are near to the beacons of the second floor, the map zone will be the second map. Another thing we can do is connect two maps in order we can provide a path between them. So we need to add a path also on the second map. For example, this is the corridor and this is the entrance. And on the first map we are going to add also a path outside to the stairs. So using the connect map tool, we're going to see both maps, and we can connect 2 points of the path between those maps. We can do this with all the floors or maps we need. This way we will be allowed to create a path between the 2 floors. And that's it for the map editor. We close and we will be prone to save the project. If we open the map editor again, we will see the project. The projects can be saved also as an XML file. This allows us to have several configurations of the same map in order we can test several scenarios. Also, on our demo we can load at runtime some maps in order to have the same application running as a generic application that can be used on different scenarios.
Once the map has been finished, it's time to set the properties of particle filter. The MCL Monte Carlo location settings are preset to work in most of possible scenarios, but in any case, because you fight with a really adverse scenario, you want to save as much as battery possible, you want to adjust the scenario, or just because you want to play, etc., we need to know how the options works and affects the MCL. Beacons to use. Number of beacons to be used in indoor positioning system. So in scenarios like a corridor and rooms, with 3 or 4 beacons will be enough, while in a big and empty scenarios will increase its number to 6 or 8. Particles number. The number of particles to be used in the MCL. So with a number around 300 particles, we have enough for most of the scenarios, but we have to know that the more number of particles, greater is the precision, but also the time of computing, therefore the battery consumption. Movement standard deviation. At time to launch the particles prediction, we use the movement standard deviation in order to expand or collapse the point cloud of the MCL. So a cloud more expanded, more possible new location prediction in case of loss, but less stability and vice versa. Signal relative standard deviation. With the signal relative standard deviation, we'll give more weight to closer beacons distance simulation. With the signal relative standard deviation, we'll give more weight to the nearest beacon, so less value, more weight to closest beacons. Motion threshold. It is a threshold where we consider that we start being in movement or stand still. A pre-calculating gives a threshold of 4 for Android and 2.5 for iPad, but that might change on depends of the device. Update interval. The refresh of the positioning system with a new value. Automatic calibration. We really recommend to calibrate each beacon separately with the system provided by the manufacturer company. So, just in the case this will not be possible, we can use an automatic calibration property that will remain active all time, trying to give an adaptive solution to each uncalibrated scenario. Calibration average. It is the percentage of the calibration TX power will use. We will ask the system to lead us from the office's entrance to the meeting room. In the way, we will change the recommended path for another one, so we'll see how the system redirects us, offering an alternative route.
Well, as you can see, we set a large meeting room as our destiny, and we start to follow the path indicated in green color. But on the first cross, we are going to take another path in order you can see that the suggested path is going to be recalculated. Also, as you can see, the suggested path disappears when the user goes over there. And that is it. We arrived to the meeting room. Okay, on this example, we have set up two maps, and we are going to see how, when we arrive to the edge of the first map, is automatically changed to the second map. Enjoy. Okay, here we are going to see how, when we enter on the corridor, more or less at the middle of it, the map is going to change to the other part of the office. Okay. On this example, we will see the possibility of fencing in adjoining rooms. This is an unfriendly environment, and fencing component can manage it. Okay, here you can see that we have two adjoining rooms. I'm going to enter on the first one. This is Diego room. And as you can see, the position is on the first room. And now I'm going to enter to the second room. Where Torquil says hello. And now I'm going to exit and go to the end to the path. So that's it.
Okay, Jorge, are you there? This is David I.
Hello.
I've never met Jorge because I haven't been to the Spain development office, but it's good to say hello anyway.
Hello to you as well, thanks.
Okay, so a few questions, and then everyone else. This technology is so cool. What you can do, put questions in the question log, and I will get to them. I had a few questions myself. Do you have advice for everyone when they should use zone versus map fencing? Is zone because you don't have a map, or does it work better for irregular shapes? What's the choice to make there? Zone fencing versus map fencing?
Okay, the zone it was made thinking about the people that actually cannot make some exactly measures of the office, or because it's quite big, and then just want to know which zones are, well, I mean, some special zones they want to know when something is happening there. And it's not necessary just to calibrate those maps and then just you use the zones. So opposite to that, when, for example, you really want to know exactly location of something, then it's better than in this case to use the fencing map, the one that we showed before, the last one. And I think that gives some answer to it.
Okay, so, and let's see. I'm getting an echo again. Why am I getting an echo? I don't know. Oh, I know why. My fault, sorry. Okay, too many headphones and headsets. So second question is there a way to know what the resolution or positioning accuracy might be? Is it down to an inch or a centimeter or less than an inch? Is there some guidance on the positioning location area?
Okay, the point actually is something that we didn't put inside yet. We were thinking about it, but the reason is something about 1.5 meters, more or less that, and I think it's enough for the purpose of the fencing at the moment.
Okay, great. So a meter and a half. All right. And then people have asked us on the beacon fencing, what do you do about multiple floors or three-dimensional positioning? Because beacons just transmit in all directions. They don't have the notion of elevation, for example. Is there any advice other than maybe using major minor, and those are your points of interest that are on different floors of a building or stacks on a warehouse, for example, full of pallets of stuff?
Okay, then the algorithm that we are using is using a special algorithm, and I cannot tell right now about it, but actually it takes the exactly beacons we need. So it's so difficult that the algorithm take for around beacons is located in another floor, because actually we know exactly the physical position of them. So if we can manage that, so it's not. It actually is working quite well with that. Thanks.
Okay, great. And again, going back to the calibration process, can you just go over calibrating beacons one more time? I wasn't sure if I put the beacons down and I take a measuring tape, and because I know I can specify beacons and distance between, accurate beacons, but that's like distance and where they're placed on a map, for example, versus the signal strength calibration. Can you explain that again, please?
All right, then the calibration normally in beacons is you have to take the measure of the R as I from 1 meter of distance. then it's not necessary just to put exactly the value. I mean, it can be one more, one less. For example, it's something like minus 72, it can be minus 71, minus 73. You can take, for example, 5 or 10 values and a medium of that. All right, the reason is for fencing concretely, it doesn't have to be quite exactly. But what we cannot have is something like, if the values has to be something like minus 63, and you have put something like minus 72, because it's giving a really wrong value of distance. Then we can find that two beacons, they are located, for example, 30 meters distance each to the other, and you are, for example, near to the first one, and both of them are giving like the same distance, like 2 meters. That I mean, giving some really bad results. So is that because it's so important to calibrate them? Then 1 meter distance, to take 5 or 10 values about the RSSA, and a middle of that will be enough.
Okay, and then I know you were showing in the video and discussing beacon placement. Is there more advice beyond just put them up high in the ceiling so that you don't have humans blocking them? You also have thickness of walls, steel, and what other things. I don't even know if you can have directional beacons, but just a few words about beacon placement and the impacts of environmental things.
Okay, as you saw in the video, we normally, when it's crowded, we are putting them on the roof. The signal can travel better. And for example, if you are sure that a beacon is going to work properly, it's because you can see it. But for example, in our algorithm for the fencing concretely, we are not using all the beacons placed. As you go so before, we are using just some of them. For example, if we have 20 or 30 inside the floor or the building, we are using, depends of the places, 3 or 4, because so in this way we take sure that those that we are using are the closest one. Places where to put them. At beginning and ending of the corridor. We found that the signal on the corridors are like something multiplying the power of the wave. So you can't really mistake the measures inside a corridor. So it's better, it's nice to put one at the beginning and another at the end, so we can detect them. Places where you want to come in, for example, rooms, to put one of them on top of the door, as you could show on the video. Corners, places where you want to change direction, places of interest. For example, you want an event in a museum, in a really interesting place, then you put a beacon, so you be sure that this place is going to be found exactly, and the event is going to be raised perfectly. I think just these things. No, just to think that you can watch them, and if you cannot watch them, just be sure that they are located one at the beginning or the end of the part that you cannot control correctly. That's it, I think.
Okay, and then two-part question. One about how many beacons are enough for a zone or an area, or how many are too many. And I think the other thing is, depending on the size of an area, for example, if you have a circular area and you put a beacon in the center, but it goes out beyond the range of the beacon, I don't know, 70 meters or whatever, then you may need to put a few beacons at some of the perimeters. Is that correct?
Okay, as I said before, I think good practice will be to put them no more in 10 meters of distance. Actually, depends of the power of the beacons. Those that we are using here are not so powerful, so we are using them not more than 10 meters actually, because the corridors are 10 meters, something like that. Actually, if you were talking about an area, for example, circular area, you can put one of them in the middle, but if it's quite big, I mean, something that is 10 meter distance or 20, you can put 4 in then around. And for a bigger and empty place, it's a really, really big, as I said, it's 10 meters something, and if an empty place, you can put, it's almost, okay, no, it's not necessarily 10 in this case, maybe it could be 15 or 20 because the signal actually is not going to find something that needs to cross. So for an office like this one, it's 10 meters. For an empty places, maybe more, 15, 20, depends, something like that.
Okay, and then as far as you're building up the XML file, you're in the map editor and you're building up all the information with points of interest and paths and areas and so on. Is there any limit in that world? I mean, other than memory and so on, does it affect the speed of discovery or applications if you end up having a, a big map with lots of information in the XML file? Is there any guidance there?
Until now, we didn't find a top of it, but actually something that I really recommend is not to, I mean, what's the property? There is a property that gives you the actual value of the predicted position. Then I recommend no more or less than each time half second. I mean, no less than half second per measure, because that is too much for the processor. Then if you get a new measure from the prediction, half second, 1 second, I think 1 second maybe is enough. It will work quite well. About to put so many beacons and maps, actually we here testing, we put a really a massive number of beacons, and it was working. So I think it's not about memory problem. It's more processor, and processor maybe not a measure less than each half second. That's it.
Okay, well, Jorge, thank you so much for the team as well for the presentations. Also, what was great is people got to see some of our employees in Alicante, in Spain, and the offices. That was a sort of a side benefit of walking around. I guess the only other thing is if you're staring at your smartphone or tablet, instead of watching where you're going, you might want to glance up occasionally so you don't bump into people or stuff. But again, thank you so much, Jorge, for presenting this BeaconFence deep dive.
Okay, thank you so much to you as well. Thanks for letting us to do this recorded. Thanks, bye.